Let's go ahead and do some nomenclature problems together. You know that unless you do problems, things really don't make sense. As you do these nomenclature problems, both in this online lecture and then afterwards, you need to also do some problems in the book and in the worksheets. As you do the problems, the system of nomenclature will start making more sense. Here are some compounds for you to try to name. Go ahead and pause the lecture and restart it after you've written names that you believe are correct, and use the nomenclature tree as a help to help you figure out how to name them. Remember, look at the front half and the back half. Identify the back half as either an ide or a polyatomic ion, and then in the front half you're going to say, is it a metal? Does it have only one charge, etc.? Okay? So stop the lecture and go ahead and try each of these compounds. Try to come up with the IUPAC name for each of these compounds, and then check your work after completing.
Zinc is the front half of this compound. Zinc is a metal. Then you ask yourself, is zinc a metal with only one possible charge? Or is it a metal that has more than one possible charge? You can either go to your book, or earlier in the PowerPoints there's a periodic table that shows that zinc always has a positive 2 charge. Therefore we just write zinc. Don't identify its charge by putting parentheses 2 after it. We look at the back half and we see it's a combination of nonmetals. So we look at the formula and find out that the formula of this polyatomic ion is acetate. We look at the front half of this compound and see that it is copper and ask, is it a metal? Yes, it is. Is it a metal with more than one possible charge? Yes, it is. Now we have to identify the charge, so we look at what's with it. Sulfate has the formula SO4 with a 2 negative charge on it. There are 2 negative charges on the back half of this compound, so there must be 2 positive charges on the front half. That means this must be copper 2. We then identify the back half of this compound and we name it as sulfate. We look at this compound and ask ourselves, is that a metal? It is cesium, and we find it in the first column of the periodic table. We then say, does it have more than one possible charge? Cesium is in the first column of the periodic table, and so it always has a positive 1 charge. So we're going to call the front half of this compound cesium. Then we look at the back half and we see that it is sulfur. No combination of nonmetals like sulfur and oxygen. It's just sulfur all by itself, so we call it sulfide. Sulfur is the first thing in this compound, so we ask, is it a metal? No, it isn't. It's not ammonium, so we know that we're going to have to use the prefix system. In the prefix system, we will identify how many in the front. It's only 1, so we just say sulfur. And then in the back there's 2, so 2 oxygens, so we say dioxide. Remember, you drop mono on the first element. On the second element you use it. We look at the front half of this compound and see that it is a combination of nonmetals. This is ammonium, so we write ammonium for the front half. Then we look at the back half and see that it's a combination of nonmetals also. And then we realize that must be hydroxide. We look at the front half of this compound and see that it is potassium and ask ourselves, is that a metal? Yes, it is. It's a metal in the first column of the periodic table. So that means it has only 1 charge possible, so we just call it potassium. Then we look at the back half of this compound and see that it is NO2, which is nitrite, which it would have a negative 1 charge on it. So we just call it potassium nitrite. Go ahead and now that you are getting familiar with naming compounds, I'd like you to take these names, and convert them into formulas. Remember to charge balance if charge balancing is necessary. And remember, what is the name telling you is the front half, and what is the name telling you is the back half. Don't forget, charge balance where necessary. Okay, for lead 2 carbonate, the lead 2 says that you have a 2 positive charge on the lead. Carbonate, we can look up the formula for it and find that it is CO3 with a 2 minus charge. When you combine these two ions, they combine in a 1-to-1 ratio because they have the same charge. So we just write lead carbonate in this manner. To do cadmium bicarbonate, we write down cadmium and its charge, and then we write the formula for bicarbonate. We see that there's a 2 positive charge on cadmium and a -1 charge on bicarbonate. To charge balance this, we're going to need 2 bicarbonates. So cadmium bicarbonate is written like this. Notice we've put a parenthesis around the bicarbonate, which we have to do when we have more than one polyatomic ion. Do not use a parenthesis when there's only one of a polyatomic ion, and do not use a parenthesis when it's not a polyatomic ion, when it's an individual element. Chlorine tribromide, we need a chlorine to start, and then tribromide tells us there is 3 bromines. Ammonium phosphate, we write the formula for ammonium. It has a +1 charge, and phosphate, which has a 3 negative charge. To charge balance this, we're going to need 3 ammoniums. So I'm going to have to put a parenthesis around the ammonium and a subscript 3. Remember, do not use a parenthesis on the phosphate since there is only one of them. Silver with sulfide. Silver has a +1 charge. Sulfide has a -2 charge, so we must have 2 silvers in combination with 1 sulfur. Now we've gotten halfway through this chapter. The problems at the end of the chapter that will cover the material that we've just covered are listed here. Make sure as you read that you do the in-text problems. Also, there are worksheets and online quizzes for you to do, posted under Chapter 3.